The RAH-66 Comanche helicopter was one of the most advanced and ambitious projects ever undertaken by the United States Army in the realm of rotary wing aviation. It was developed during a period when technological innovation in military aviation was accelerating rapidly, and the U.S. was committed to maintaining superiority in every domain of warfare. The project emerged from a broader vision of transforming battlefield reconnaissance and light attack capabilities using stealth, precision, and advanced electronics. Though ultimately cancelled before entering full production, the Comanche program left a lasting legacy in defense planning and aircraft development. The origins of the Comanche date back to the late 1970s and early 1980s, when the Army began evaluating future helicopter requirements under a series of modernization initiatives. One of these was the Light Helicopter Experimental (LHX) program, which sought to develop a new class of rotorcraft that could fulfill both scouting and attack roles, replacing aging aircraft such as the O-58 Kiowa and potentially complementing or even replacing heavier attack helicopters in some missions. The idea was to create a highly survivable platform that could operate in contested environments and provide real-time intelligence and precision firepower. Boeing and Sikorsky were selected as the primary contractors for the RAH-66, and the program moved forward into design and prototyping in the early 1990s. From the start, the helicopter was intended to be revolutionary. Its design incorporated low observable technologies, including radar-absorbing materials and airframe shaping that reduced its radar cross-section significantly compared to conventional helicopters. This was not simply a matter of adapting fixed-wing stealth techniques to a rotorcraft, it required original engineering to manage the unique acoustic, thermal, and aerodynamic signatures of a helicopter while maintaining mission performance. In addition to its stealth characteristics, the Comanche was engineered for speed, agility, and survivability. It featured twin engines for redundancy and power, fly-by-wire flight controls for responsiveness and reduced pilot workload, and a digital cockpit that integrated all mission systems into a seamless interface. The avionics suite was one of the most sophisticated ever installed in a rotorcraft at the time, designed to allow the crew to detect, identify, and engage threats before being detected themselves. It also supported networked operations, meaning it could share data with other platforms and contribute to a broader battlefield intelligence picture. Armament was another core feature of the design. The Comanche housed its weapons internally to maintain a low signature, including guided missiles and a 20mm cannon. It also had the option to mount additional weapons on external pylons when stealth was less critical. This gave it the flexibility to conduct both reconnaissance and offensive missions, depending on operational requirements. The Comanche underwent significant testing throughout the 1990s and early 2000s. 2 full-scale prototypes were built and flown, validating many of the design's innovative features. Engineers and military personnel involved in the program consistently reported that the aircraft met or exceeded expectations in key performance areas. Its maneuverability, sensor performance, and low observability were all considered successful achievements. As the prototypes flew and data was collected, confidence in the technical merits of the helicopter grew. However, by the early 2000s, the strategic environment had shifted dramatically. The threats the Comanche was designed to counter, heavily defended mechanized forces and integrated air defense systems, were no longer the central focus of U.S. military operations. The priorities had moved toward irregular warfare, counterterrorism, and operations in low-threat environments where stealth and advanced survivability features were less essential. In this context, the Comanche's high development and projected production costs became increasingly difficult to justify. By the time the program was canceled in 2004, approximately $7 billion had already been invested. The total projected cost of full production exceeded $30 billion, a figure that was viewed as unsustainable given the changing nature of warfare and competing budgetary demands. Instead of continuing with a full production order for hundreds of Comanches, the U.S. Army chose to redirect resources into upgrading existing helicopters, improving sensors, and expanding capabilities in unmanned systems and digital battlefield integration. Despite its cancellation, the Comanche program is not considered a failure from a technical perspective. On the contrary, it is widely viewed as a case of technological success but strategic mismatch. The aircraft delivered what it promised in terms of performance and innovation, but it was simply no longer aligned with the operational requirements of the U.S. military. The decision to cancel was based on a rational reassessment of needs rather than a rejection of the aircraft's capabilities. In the years since, the technologies pioneered during the Comanche program have continued to influence U.S. military aviation. Elements of its flight control systems, stealth shaping, materials science, and digital integration have informed the development of other platforms. The program also provided valuable lessons in procurement, systems engineering, and the risks of aligning major defense acquisitions with narrow threat scenarios that may change over time. The Comanche remains a symbol of what happens when engineering excellence meets changing strategic reality. It demonstrated the ability of American industry and defense institutions to push the boundaries of what is possible, even if the result is ultimately set aside due to broader considerations. The two flying prototypes serve as a tangible reminder of this chapter in aviation history. While the program did not reach the battlefield, it contributed to the ongoing evolution of how the United States approaches rotary wing combat capabilities in a complex and dynamic global environment. Today, there is no active production or revival of the RAH-66 Comanche. The aircraft remains a part of defense archives, and its legacy lives on primarily through the technologies it introduced and the institutional knowledge it helped build. The experience continues to inform how future systems are planned, tested, and integrated into the larger defense ecosystem. The program stands as a high point in aerospace engineering, with outcomes that reflect both the possibilities and the limits of long-term military planning in a world that does not stay still.